we are going to continue to maximize your areas and minimize your perimeters. Before, where we maximized your x times y, your product will now be your area of a rectangle that is represented by x as the length and y as the width. So we have a let statement that says let x equal the length, let y equal the width. So now, where we did a product, x times y, the area will be x times y, which is still a product. If we're dealing with a perimeter and you're dealing with your rectangle, xx, yy, your perimeter is 2x plus 2y. Or, we'll factor out a 2, make life easy. Here's our perimeter formula. So we're going to substitute in the 100 feet. And we're going to have to solve this for y so that we could replace this in your y1. So we'll divide by 2. And we'll subtract out the x. So we're going to plug it into your y. So in your calculator, you are going to have in your y1 as this. It's a maximum. You see it turned down. X times negative x gives you negative x squared. You're looking for a maximum. You find your maximum at 25,625. This is your x. This is your maximum area. Now come back to this equation and plug in your x. Therefore, y is also equal to 25. So you have solved your sides of your rectangle so that you can maximize your area when your perimeter is 100 feet. When you get to number 6, it's basically the same thing, except for your 100, you're going to use your 36, and you're going to calculate it based off of that. In number 8, in number 7, we're going to minimize your perimeter. So remember your perimeter formula and your area formula for your rectangle. You're still dealing with the rectangle with a length of x and a width of y. When we minimize your perimeter, this is like your sum. When we minimized your sum, we go to y1 and we put in your perimeter formula. Now you're given for this one that your rectangle has an area of 64. So your area formula is x times y. So we substitute in the 64. Let's solve for y. And we substitute that into your equation. So in your y1, you're going to put in this equation, and you're looking for a minimum. You're looking to minimize. Remember, this is half of a hyperbola, so that it's kind of at a slant. You'll find your minimum, plug it in, find your minimum, and your minimum should be at 832. 8 is the x, and 32 is the minimum perimeter. Bring it back to this equation. Y is equal to 64 divided by 8, and y is equal to 8. So when x is 8 and y is 8, you have a rectangle in which you maximized your perimeter. Now when you do number 8, this is your y. Your v is your x. But remember, look at your table. Look at your y values. Your y values are a flow rate. Your x represents the speed of traffic. Your flow rate has to be small. A rate of 30% is going to give you a 0.3. So a heads up, you might want to set your window, your y min to 0 and your y max to 1. And then you can work on your x's. Your x min has to be 0, but your x max is going to be a lot larger because you're looking for a speed. So maybe even go to 100 or go to 30 or 50 and try that.